day everyone. So for today's video, I'm going to discuss to you about bubble sort and merge sort. So first, let me introduce myself. I am Rose Anjoy Dimamay, a second-year college student, taking BS IT as my course. So now we are going to discuss to you about bubble sort. So first, let us define what is bubble sort. Bubble sort are orders a list of values by repetitively comparing neighboring elements and swapping their position if necessary. More specifically, first is scan the list, exchanging adjacent elements if they are not in relative orders. This bubbles the highest value to the top. Next is scan the list again, bubbling up to the second highest value. So lastly is all we have to do is repeat until all the elements have been placed in their proper orders. So what are the advantages and disadvantages of bubble sort? This algorithm has several advantages. It is simple to write, easy to understand, and it only takes a few lines of code. The data is sorted in place, so there is a little memory overhead, and once sorted, the data is in memory and ready for processing. The major disadvantages is the amount of time it takes to sort. The average time increases almost exponentially as the number of table elements increases. 10 times the number of items takes almost 100 times as long to sort. So now I'm going to give you an example of bubble sort. So as you can see, bubble sort compares the number in pairs from left to right. Higher number, all we have to do is to move it from left to right. So on our first numbers, since 9 is the highest, is higher than 6, all we have to do is swap them. So it's gonna be 6 and 9. Next, 9 and 2. Since 9 is still higher than 2, all we have to do is swap them. Next, 9 and 12. Since 9 is not higher than 12, there is no need for swapping. So let's go on our next step, which is 12 and 11. 12 is higher than 11. All we have to do is swap them. On our last three numbers, since 12 is higher than those three numbers, we do the same, just swap them. 9 and 12, 3 and 12, and it's gonna be 7 and 12. So here I'm just going to circle all the comparison that we have discussed. So first, 1, 2, 3, 4, 5, and 6. Notice that this time we do not have to compare the last two numbers, as we know that 12 is in position. This pass therefore only requires 6 comparison. So next we're on the third pass. All we have to do is draw some circle here. 1, 2, 3, 4, and 5. So this time, the 11 and 12 are in position. This pass therefore only requires 5 comparison. Next is on our fourth pass. Just draw some circle. 1, 2, 3, and 4. Each pass requires fewer comparison. So this time, we only requires 4 comparison. So on our fifth pass, just draw again. 2 and 3. The list is now sorted, but the algorithm does not know this until it it completes a pass with no exchange. So we're gonna do that on our last pass. Put some circle on the last two. This pass, no exchange are made, so the algorithm know that this is sorted. It can therefore save time by not doing the final pass. With other lists, this check could save much more work. So that's how you sort a bubble. So next is merge sort. What is merge sort? Merge sort is one of the most popular sorting algorithms that is based on the principle of divide and conquer algorithm. Divide and conquer strategy. Using the divide and conquer techniques, we divide a problem into a sub-problems. When the solution to each sub-problem is ready, we combine the results from the sub-problems to solve the main problem. The merge step of merge sort. Every recursive algorithm is dependent on a base case and the ability to combine the results from the base cases. Merge sort is no different. The most important part of the merge sort algorithm is, you guess it, and merge step. The merge step is the solution to the simple problem of merging two sorted list arrays to build one large sorted list array. The algorithm maintains three pointers, one for each of the two arrays, and one for maintaining the current index of the final sorted arrays. So these are the example of merge sort. So here, I'll show you 6 numbers. All we have to do is to divide this into 2. Divide this into 2, so it's gonna be 2, 8, 5, and 3. Next is 9, 4, 1, and 7. Do the same, just divide them. So it's gonna be 2, 8, 5, 3, and for here, divide this 2, so it's gonna be 4, 9, and 1, 7. Do the same on the rest. Divide it, so it's gonna be 2 and 8. 5 and 3. 9 and 4. Lastly, we have 1 and 7. So next, since they're all separated, all we have to do is to box them into 2. So here we have 2 and 8. All we have to do is to swap them. So it's going to be 8 and 2. Do the same on the rest of the numbers. 5 and 3, so it's going to be 3 and 5. 9 and 4, it's going to be 4 and 9. Lastly, 1, 7, so it's going to be 7 and 1. Next is we have to put them all together into 4 boxes. And this time, all we have to do is to put the lower number to highest. So it's going to be here, since 8, 2, 3, and 5. So we put it on the lower number to highest. So it's going to be 2, 3, 5, and 8. Next is 4, 9, 7, 1. So it's going to be 1, 4, 7, 9. Then put them all and sort it by lower number to highest number. So this is the result. 1, 2, 3, 4, 5, 7, 8, and 9. So this is so easy to do for merge sort. So that's all. Thank you for watching.